Hello friends, today we are going to discuss indefinite integrals. Now in this chapter we shall study an operation which is inverse of differentiation. We now want to study the problem when the derivative of a function is given and we have to determine that function. The process of determining such a function is called as integration. Consider the following examples. Suppose that we want to determine a function whose derivative is 4x cube. We know that ddx of x raised to 4, that is derivative of x raised to 4 with respect to x, is 4x cube. Therefore, the required function is x raised to 4. Here, x raised to 4 is called integral of 4x cube with respect to x, and this is written as integral 4x cube dx equal to x raised to 4. The symbol, this particular symbol, is called an integral sign and was introduced by famous mathematician Leibniz. Now why this sign only? You will appreciate that this seems to be an elongated S. Yes, it is an elongated S only, English alphabet, because an integral can be expressed as the limit of sum, S-U-M, sum. So if you consider the first letter of the word sum and if you elongate it, you get the sign of an integral. Now what does dx stand for? Here dx indicates that the variable of integration is nothing but x. Suppose that we want to determine a function whose derivative is cosec x into cot x. We know that ddx of minus cosec x is nothing but cosec x into cot x. Therefore, the required function is minus cosec x. Using integral sign, we can write integral cosec x into cot x dx equal to minus cosec x. Please do not read this as integral cosec x cot x into dx. We are not supposed to multiply by dx. Dx tells us that the variable of integration is what? X. Actually, we can say that integral cosec y cot y dy is nothing but minus cosec y, because here variable of integration is y, so we use dy. Now, what is the definition of integral of a function? If f of x and g of x are two functions such that ddx of f of x equal to g of x, then f of x is called an integral or an antiderivative or a primitive of g of x with respect to x. It is denoted by integral gx dx equal to fx and is read as integral of g of x with respect to x is f of x. Here we say that g is an integrable function. So what do you mean by an integrable function? A function whose integral can be obtained is called as an integrable function. The process of finding the primitive or integral of a function is called an integration. Thus, integration is the inverse process of differentiation. Friends, actually we have considered or we have already used many inverse processes. I'll give examples. What is 4 cube? It is 64. So can I say that from this 4 is cube of 64? No. Cube of 4 is 64. So 4 is cube root of 64. So finding cube root is the process which is inverse to find the cube of that particular number. I'll give one more example. What is log 2 to the base 10? It is 0.3010. So can I say, so from this 2 equal to log of 0.3010? No. Log 2 is 0.3010. So 2 is antilog of 0.3010 to the base 10. So taking antilog is the process which is inverse to taking log value. Is that clear? Now ddx of x raised to 4 is 4x cube. Therefore integral 4x cube dx is x raised to 4. But what is ddx of x raised to 4 plus 7? It is again 4x cube. What is ddx of x raised to 4 minus 5? It is again 4x cube. Why this is so? Because derivative of any constant is 0. So what is your observation here? Can you generalize the result from this observation? Yes. So in general, ddx of x raised to 4 plus c is 4x cube, where c is any constant. And therefore we can say that in general, integral 4x cube dx is nothing but x raised to 4 plus c. The number c is called the constant of integration. Hence, if ddx of fx equal to g of x, then integral g of x dx equal to f of x plus c. For different values of c, we get different integrals of g of x. And hence the name indefinite integral. Remember, if derivative of a function exists, it is unique. But integral is not unique. And that is why we say it is indefinite integral. And therefore, integral g of x dx is nothing but f of x plus c, and it is an indefinite integral. I'll give one more example. What is derivative of x cube minus 8 e raised to x plus root x? I have taken simple example. Derivative of x cube is 3x square. Derivative of e raised to x is e raised to x. Derivative of root x is 1 upon 2 root x. And therefore I can say ddx of x cube minus 8 e raised to x plus root x equal to 3x square minus 8 e raised to x plus 1 upon 2 root x. Therefore, integral of 3x square minus 8 e raised to x plus 1 upon 2 root x dx is nothing but x cube minus 8 e raised to x plus root x plus c. Now you may ask me, why not to consider constants for each of these three? Say c1, c2, c3. Yes, you can consider that. But again, c is an arbitrary constant. So I can say c1 plus c2 plus c3 is another constant, say c. Now from the above discussion, it is clear that the integral is an inverse operation of differentiation. Hence it is called antiderivative. In integral fx dx, fx is an integrand and x is a variable of integration. Now we discuss integrals of some standard functions. We already know the formulae of derivative of many standard functions. From these we shall establish the formulae of integrals of some standard functions. First, ddx of x raised to n plus 1 upon n plus 1 is x raised to n provided n plus 1 is not equal to 0, that is n not equal to minus 1. And therefore I can say that integral x raised to n dx equal to x raised to n plus 1 upon n plus 1 plus c, n not equal to minus 1. This should be minus 1, not 1. Second, ddx of log x is 1 upon x. So integral 1 upon x dx is log of mod x plus c. Now why to consider modulus value? Because logarithm of 0 and negative numbers are not defined. Logarithm of only positive numbers are defined. Third one, ddx of x is 1. So integral 1 dx is what? X plus c. Actually there is no need to say integral 1 dx. Just say integral dx equal to x plus c. Fourth one, ddx of root x is 1 upon 2 root x. So you can remember this as a standard result, that integral 1 upon 2 root x dx is what? Root x plus c. ddx of sin x is cos x. Therefore, integral cos x dx is nothing but sin x plus c. What is ddx of minus cos x? It is sin x. Therefore, integral sin x dx is nothing but minus cos x plus c. ddx of tan x is sec square x. Therefore, integral sec square x dx is nothing but tan x plus c. ddx of minus cot x is cosec square x. Therefore, integral cosec square x dx is nothing but minus cot x plus c. ddx of sec x is sec x tan x. Therefore, integral sec x tan x dx is nothing but sec x plus c. The next result, ddx of minus cosec x is cosec x into cot x. Therefore, integral cosec x cot x dx is minus cosec x plus c. What is derivative of e raised to x? E raised to x, and therefore antiderivative, that is integral e raised to x dx is e raised to x plus c. ddx of a raised to x upon log a is a raised to x. Therefore, integral a raised to x dx is a raised to x upon log a plus c. So at the end of the lecture, I would like to tell you that Karl Marx, you must have heard about Karl Marx, the famous writer of Das Kapital. Karl Marx used to solve sums on integration while writing Das Kapital. So I ask students, at least you should do integration for getting marks. So on this lighter note, we complete today's session on indefinite integral. We'll meet next time. Till then, bye bye. Thanks.